Today we're going to solve a quadratic linear system of equations graphically. You can use the date of May 19th. Your note should have 3 pages, and you're going to want to grab a ruler or some kind of straight edge. When we graph a quadratic linear system, we have 3 possible solutions. The first is that the quadratic equation and the linear equation do not intersect at all. Another possible solution is that they do intersect, but they have one point in common, or they intersect and have 2 points in common. So we're looking for one of these 3 options when we solve our quadratic linear system. So the procedure that we're going to follow is you're going to draw both graphs on the coordinate plane. For the linear equation, you're going to want to put it in slope-intercept form, and then you can graph it using the intercept and the path of the slope. The quadratic should also be in standard form, and typically I put that into my iPad and let the iPad generate a table, and then I just plot my points. Once everything is graphed and labeled, we want to locate our point or points of intersection. Those are the solutions that we're looking for. And you want to make sure you write the solutions as ordered pairs somewhere around the graph or on the graph. We definitely want to check that the solutions are valid. You would sub them into the original equations, and you'd have to sub them into both the quadratic and the linear. For the sake of time, though, we can check it on the iPad since we're using that to help us visually, and we should be able to see the points of intersection. So for example 1, we're going to start with this quadratic equation. If you want to take a minute and put that into your iPad so that you can get a visual, and then we'll let it generate a table for us. When I look at the graph, I can see that the turning point is here at 1, 0. So when I build my table, I do want to have that in the center of the table. And then I'm going to use 3 values that are smaller than 1 and 3 values that are larger. Remember, we should see this repeating pattern in our Y column. Now I want to graph my linear equation. This equation is not in slope-intercept form, so I'm going to subtract x from both sides. And now that it's been rearranged, we can start graphing on the y-axis at +3, and then we're going to drop 1 unit and go to the right 1 unit. Drop 1, run 1. When I do that, I can see that they have 2 points of intersection. Right here, it looks like it's at 2, 1. And then on the other side, it looks like -1, maybe 4. I want to make sure I get the exact location, so I'm going to ask the iPad to make a table. Now, when you have 2 functions graphed, you can get both functions tables to display at the same time. So the first column are your x values, your domain. In the second column, this is my quadratic equation. And then in the third column is my linear equation. What I'm looking for is to have the y values that are the same. Now we thought we saw at -1, 4 a point of intersection. This shows me that the y values are the same. We also thought at +2, and sure enough, the y values are both 1. So now that we've identified the points of intersection and they are exact locations, we're going to state our solutions as -1, 4 and 2, 1. In example number 2, we're going to use the same quadratic. So I'm bringing up the same table and the same graph. The second equation, though, is linear. And we're going to put it in slope-intercept form. I'm going to subtract x and subtract 3 from both sides. And that results in y equals -x minus 3. So what you can do is at the top of your iPad, we have the circle with the plus inside. We're going to tap that, and we're going to add our linear function. And when you do, you can see the linear equation is graphed, but it doesn't intersect our quadratic at all. So even though they don't have any points of intersection, we need to tell the reader that there are no solutions. So somewhere on the graph or next to the graph, you need to state no solution. This will be homework number 118. This is in your packet. I'll make sure that I attach a digital copy as a PDF. If you have any questions as you go through these notes or this homework, please make sure you contact me. Have a great day.